So, good evening, everyone. Hope I'm audible. So, good evening, everyone. Welcome back to ICE platform. I'm Neelam Parshuram from IC Ventus team. Thank you all for joining us once again this Tuesday. For those who are attending this for the first time, welcome to our weekly webinar series where every Tuesday we connect with professionals, experts, and learners from the elevators and escalator industry on one common platform. While we wait for few more participants to join in, I'll take a few minutes to explain what does the IC do and how do we work with the industry. So ICE platform is designed to share practical insights, uh, practical knowledge, industry insights, and real world experience that can help you grow professionally and stay updated with the latest development in the industry. We are glad to see participants joining in from different locations, and we truly appreciate you taking time out of your busy schedule to learn, to gain insights, and to upgrade your knowledge with us today. So, it's an initiative by IC Ventus. IC Ventus also organizes exhibitions, trade shows, and industry events. We create a platform that supports learning, collaboration, and business growth. So, IC vendors have become a trusted bridge connecting regional markets with the global opportunities. We'll go through our upcoming shows. So first is IC India 2026. It will held on 3rd, 4th and 5th December in India, proudly making the capital city the host of this year's edition. With a strong industry support, IC have grown to become the fourth largest exhibition for elevators and escalators, reflecting the trust and collaboration of the entire industry. So this year's exhibition is planned across a massive area of 40,000 square meters, making it one of the largest gathering of the vertical transportation industry in India. So please plan in advance. We strongly recommend you to plan at least for 2 days to experience the scale, the innovation, and the opportunities this exhibition has to offer. Next is I See the Monsoon Edition in Chennai, featuring the quiz, the symposium, and the dynamic industry exhibition. It is scheduled for August 5th, 6th, and 7th in 2027 in Chennai Trade Center. So, this monsoon edition reflects the Chennai's regional weather calendar. Held before the monsoon season, it creates a perfect time for the industrial professionals to network, to plan the upcoming projects, and to discuss solution before the operational slows down, typically caused by heavy rains. Next show is IC Africa 2027. This will be held from 24th, 25th, 26th November at KICC in Nairobi. So Kenya is one of the fastest growing infrastructure market in Africa, creating strong opportunities for the elevators and escalator industry. So this exhibition will bring together global manufacturers, suppliers, and industrial professionals to showcase their innovative and to create a safe vertical mobility solution for the growing Africa market. Next is IC papers. So vertical transportation industry has always been built on knowledge shaped by experience, innovation, and real world challenges. Yet much of this knowledge often remains scattered, undocumented, and limited to the individuals and organizations. So that's why IC Papers is created. This is a platform where you can share your knowledge, showcase your journey, and also you can connect with the industrial professionals. So this platform is built by the industry and for the industry. So you can share your learnings, you can share your all your matters, you can connect with this industry here. So if you are part of this vertical transportation ecosystem, this platform is for you. If you want to share all your details, you can contact Miss Sonal Aire. I've shared the contact details here. You can also visit our website, which is icpapers.com, and also you can connect on social media as well to get the daily updates. So coming up to our today's session. So today's session, let's turn our attention to one of the most important conversation shaping the future of elevator safety and technology. As control panel becomes smarter and more advanced, understanding the latest safety standard is more important than ever. So to help us decode IS 17900 and understand what this new requirement mean for a modern control panel design, we have with us Mr. Subramanian Bharathiyar. So, with over 24 years of experience in the vertical transportation industry and professional experience with the TK elevators, with Otis, Schindler, and with Inovance India, Mr. Bharathiyar brings a wealth of technical and industrial expertise to this session today. Also, Innovance will be exhibiting in IC India 2026. You can visit them at booth number 1C21 in Hall 1. A quick note to the audience. You can drop down your questions in the chat box during the session. We will take up this question at the end during Q&A round. So with that, without any further delay, we would like to welcome Mr. Subramaniam for today's session. Decoding IS 17900, the next generation safety standards for modern control panels. Over to you, sir.
Thank you, Neelam. So, good evening, everyone, and thank you to YEC for giving this opportunity to present my presentation about our latest 17 IS 17900 standard. Myself, let me share my screen. Neelam, my screen is visible, right?
Yes,
Hey,
sir.
Neelam?
We can see your screen.
Okay, thank you. Okay, myself, I'm Subramania Bharathiyar, known as Subra in the industry, and I'm being here in this company in Inovance for past 14 years, and I'm be here in the industry for past 24 years. This company, Inovance, it's a parent company, and the elevator segment is Monarch BST, well-known brand name across India and globally, and Monarch BST is part of Inovance. Let me go through about our company with a few slides, then next we will go to the core content. So this is a glance at our Inovance. As a technology pioneer and solution provider, we are dedicated to bring your reliable partner and making automation easier and closer. Our mission and vision, advance industrial technology for a better world. This company founded in Shenzhen 2003 during the China's manufacturing transformation. And Inovance has spent more than 20 years of advancing industrial automation technology. And we are specialized in the different industry, including the elevator industry. This is about the Inovance number, founded in 2003, IPO'd in 2010 Shenzhen. And we have got more than 30,000 employees with a revenue of 6.6 billion in 2025, with a CAGR of 22%. And we have got 28% of R&D staff. That is one of our core area. And with the R&D investment of close to 0.62 billion, close to 10% of our revenue. And we have got a patent more than 3,000. And we have got 18 manufacturing site globally. And we are also aiming on the carbon emission annually, which is metric ton of 14.44 million. So this is our global footprint. And you can see here we have got a big area of factory in China. Then we have got our SBS in South Korea and Hungary, in India, started in 2012, and Thailand too. This is our glance about our global footprint. And this is our Inovance India, founded in 2012. Currently, we are having more than 250 people employing in Inovance India, at office in Chennai. And we have got a 65 plus channel partners and service partners, more than 25. And we have got a two warehouse, including one warehouse being used for their manufacturing from last year. And we have got one more facility in Surat. We have got a certification of IS 9001, 14,000, and 45,001. So we are number one for the complete elevator package for the elevator. And we are also number two in the plaster injection, since we are into the different industry. These are our main core business unit, industrial automation and distillation, where we can see the intelligent elevator, which is contributing close to 740 million USD with the annual growth of 5%. And we are also into the new energy vehicle and industrial robot and digital energy. And we are market leader on this segment, and which including the elevator segment, where we are contributing close to 29.5% for the interface, and for the control system we are contributing 39.1% overall. So that's all about the brief about our company. So let us get into the topic. So since I know we are going to discuss about our BSA 30, the 17900, I'll just give us some glance, because the purpose of is to establish comprehensive safety rules for the design, installation, maintenance of the lift and escalator in India, aligning them with the international code like ISO 8100 and EN 8120 in 81 to significantly enhance passenger safety, prevent accident, and ensure responsible operation, covering aspects like door safety, emergency power, and structural integrity. It replaces older codes such as IS 14665, IS 15785, and IS 14671, making it legally binding for owners, manufacturer, and maintenance provider to improve the vertical transport industry safety and reliability. The core improvement, if you look at the safety improvement related to the passenger, safety improvement related to the service engineer, safety improvement related to the equipment, which brings, that our IS 17900 is bringing these improvements, safety improvements. So we have got a different part of IS code, and these are the list published by our Bureau of Indian Standard. So these are the complete breakdown. We can see IS 17900 part 1, part 2, part 3, part 4, part 5, part 6, and 7, 10, and 11, and 20. So currently, actually, everyone knows that the Indian government enforced to implement our IS 17900 part 1 and part 2, which was published in 2023. And now it is being implemented across India to follow. Here, what we do, we will mainly focus on the part 1 and part 2, because we have got a limited time to present, and the subject is very long and big. So we will mainly focus on the electrical and the control panel side. So what are the deep understanding of the product, and what and all we need to focus on to implement this code. And even the coming slide, it will be not be more explained, but it will be brief enough to understand the code, which is trying to explain us about our requirement for the IS 17900 standard. So we'll go through the part 1, which is lifts for the transport of 1,000 and goods part 1, safety rules, published in 2023. So now the coming slide, we will mainly focus on the key points, which is related to the electrical part as well as the control part. And I'm not going through any of the mechanical part, since the session is purely on the technically for the electrical part. So we will start with every important points which is related to our control part as well as the electrical part. So the first one comes to the lighting requirement. Since it is very clearly stated for the people who are walking around and in the lift, the well shall be provided with permanent installed electrical lighting, giving the following intensity of illumination even when all doors are closed at any position of the car throughout in travel in the well. So if you look at least 50% lux, 1 meter above the car roof within its vertical position, we must ensure minimum 50% lux. And at least 50% lux, 1 meter above the pit floor and above the pit platform. Everywhere a person can stand, walk, and move around between the working area. And at least 20 lux outside the location defined in A and B, the first two, excluding shadow created by car and components. So these are the minimum lux needed inside shaft for the people to work and move around or do the activities to maintain the elevator working. Apart from the shaft, the machinery space also, saying the space and the pulley, it needs minimum 200 lux at floor level everywhere at the person needs to walk, especially for the machine room, space, pulley room, and shall be provided with the permanently installed electrical lighting. And 50% at the floor level to move between areas. So this supply for the lighting shall be in conformity with 5.10.7 and 1, which is again is electrical appliance category, and electrical equipment in the pit and in the machineries. So again, even for the pit, so equipments where what and all we have to place, like electrical equipment in the pit and machinery space and pulley rooms, shall be suitable for the environment protected against the mechanical damage. Wiring shall be protected and suitably supported. Equipment shall be easily accessible for the inspection, operation, and maintenance. These are the key points we need to focus and follow. Here comes to the next part, the machinery space and pulley room. What and all we need. The first one is a lighting control switch, a switch accessible only to the authorized person and placed close to each point at appropriate height, controlling the light in the area spaces. So you can see the representation of the picture where the pressure height, which is lying between 1.2 1.8 meter from the floor level for the easy access of light. And socket outlet, at least one socket outlet provided at appropriate places for each working area. Wherever since we are in the mission room, whenever we do an activities, we should have a socket outlet to use our equipment. And stopping devices, yes, stopping devices in conformity with the 5.12 1.11 installed in the pulley room close to the each point of access to ensure to shut down the elevator operation before we start to work. So the next one, working area in the pit, location of stop switches and pit access equipment. And you can see here the different the requirement, the pit depth, which is 1.6 or less than 1.6. We can have a single stop switch with height of maximum 2 meter from the pit, and at the same time from the landing 400 meter above the lowest landing floor level for the easy access before entering to the pit. If the pit depth is more than 1.6, two stop switches are recommended here. One is with the height of from the floor level 1 meter, and the bottom one with the height of maximum 1.2 meter from the pit floor. This is to ensure the proper entry of the pit by enabling the top switch first and then get into the pit to enable the secondary switch. Because when the depth of the pit is getting increased to the 1.6, these two stop switches is mandatory as per the new norms. And apart from that, if the pit access is having the door, single stop switch within the horizontal distance of 0.7 meter from the access door from inner side edge at 1.2 meter, the maximum height from the pit floor. So these are the key point. And the stop switch can be combined with the inspection station required in B. An inspection control station, a permanently installed inspection control station according to the 5.12, 1.2, and operable with the 0.3 meter from the refugee base. So we need an inspection station in the pit to move the elevator whenever we needed to do any maintenance or working activities. And satellite outlet also in the pit shown here, and well lighting switch means two switches. The well lighting position within the maximum horizontal distance of 0.75 meter from the pit access door from inner edge at a minimum height of 1 meter and above the floor level. So this is the requirement mainly for the working area in the pit for the the technician to utilize during his work. So next point is this is a 5.2.6 and device for the emergency test operation. The necessary devices for the emergency and test operation shall be provided on panel to carry out from the outside wall, including the emergency panel should have, we should able to see the running direction of the elevator when we are doing working from the emergency panel. And we should also have an indication to know the unlocking to means door zone of the elevator whenever it is arrived, reaching the door zone, the indicator should indicate. And we should also see the speed of the elevator to ensure the elevator speed is within nominal speed, with a test function switch, to activate, disable, and put into the normal. So this and all, the devices for the emergency and the test operation are needed in the panel. Normally in the landing for the MRL landing, control panel or in the mission room. So here comes the next point. This is related to the automatic power operated door. The important point is here, since it's related to the control function, the kinetic energy limit. There is a limitation for the kinetic energy. So the kinetic energy of the landing or the car door and a mechanical element which is originally connected to it, calculated and measured at the average closing speed shall not exceed 10 joules. For whatever with the distance, whatever with the weight. So we have to ensure that it should not reach more than 10 joules. So the parameter setting and the selection of door drive and speed, everything has to be considered while we are adjusting this one. And productive device for the reopening. So this comes to the sensor. So the productive device is important here. The productive device shall cover the opening over the distance between at least 25 mm from the bottom and above the level of 1600 mm above the car door sill. The productive device shall be capable of detecting obstacles within a minimum diameter of 50 mm. That is important. And to counteract persistent obstructive in the closing door, the productive device may be deactivated after predefined time. But in case of failure of productive device, the door sensor or deactivation of the productive device, the kinetic energy of the door shall be limited to 4 joules, which is, we have to reduce the speed absolutely, because the normal operation should not reach beyond 10 joules. And the lift is kept in operation and acoustic signal shall operate at any time the door is are closing, to ensure that even the door sensors not function. We have to ensure that the door can be closed with the joules not beyond the connecting energy not beyond the 4 joules, with the acoustic signal, to ensure that if someone is standing or they should know the door is closing. So this is the record standard for automatic power operated doors. Here comes to the ascending curve over speed production. This is ACOP. The mean comprising speed monitoring and speed reduction element shall detect overspeed and ascending curve and cause the car to stop, or at least reduce its speed to that which the counterweight buffer is designed. So this CACOP, when it has to act active in normal operation, manual rescue operation, or automatic rescue operation, unless there is a direct visual aspiration, especially for the manual and automatic, to ensure that if we have a direct visualization, not a problem. Unless if direct visualization is not possible, we should have a limitation with the ACOP function. And the action of ACOP function is independent performance and self-monitoring. It should ensure that independent performance and self-monitoring for the speed of the elevator and control logic and the reducing element. So the ACOP can act on car, counterweight, or rope system, the traction shoe, which is we can consider as a brake, and the same shaft as the traction shoe, provided that the shaft is only the statically supported in 2 points. And next, when we are having ACOP functions, any supplier, when they are supplying, the data plate is important with the name of the manufacturer, actual tripping speed for which it has been adjusted, type of ascending curve of speed production means. So this is the basic reason. And during the actuation of the ACOP, the maximum retardation should not be more than 1G. The maximum is 1G. Yeah. So after the ACOP, here comes the UCMP, unhindered car movement protection. So UCMP prevents unhindered movements of the car when the doors are open and the landing is not locked. So this condition will appear, when we are doing the releveling in the floor level. If the available between the car and the landing is differ, then the system try to bring the elevator back to the floor level by keeping the door open. So during this action, the UCMP is important because it monitors the electrical state of the brake and the door lock zone. If any unsafe condition is detected, the safety circuit is open and the car is prevented from moving. So you can see here the UCMP electrical basic concept electrical safety diagram, that door lock monitoring, brake lock monitoring, and the car position. These are the three key points as to be considered during the UCMP action. And finally, all this monitoring comes to the UCMP safety relay or the functional device, which reacts immediately to apply the brake if you are using the brakes for the UCMP function. So ECMP function ensure the car cannot move unintentionally when the landing doors are open and the unlocked door zone is not achieved. If enough the following occurs, ECMP open the safety circuit. Door lock is not engaged, one or more brake are not applied, car is not in unlocked zone. The key feature, electrical monitoring, all safe relevant states are monitored and electrically using NONC contact. Redundancy, dual brake monitoring, dual brake channel UCMP relays are high reliability. Fails if any fault or loss of power causes the safety circuit to open. And it has to confirm with our IS or ENO 8120 years, which is part 1 and part 2. So why it is needed ECMP? To protect passenger from falling into the lift well due to the unintended movement of the car when the landing door is not locked and the car is not closed. So you can see two cases. One is car is moves towards and downward unintentionally, because during the correction mode, if something goes wrong and if the lift start, because we are keeping the brakes open, there is a possibility, because if the car is loaded and if the brake is kept open and if we are not controlling the machine, the possibility of the car move down is highly possible. So the case one. And the case two, when the releveling is taking place up and if the system lose the control, there is a possibility the lift will go further up and the possible fall hazard inside the pit. The first case inside the car and the second case inside the pit. And again, we have to consider the door operation also here. So a key safety requirement, prevents or stop unhindered car movement away from the landing, works for up and down direction, acts independently with the self-monitoring. Stopping distance, that is important, that stopping distance less than equal to 1.2 or less than 1.2, gap at the sill not greater than 200 mm. A clear height greater than clear height, it should not be greater than 1 meter. And retardation is the same like ACOP. The elevator stopping impact should not be more than 1G. Even upward empty car within the limit for the down direction. And detection by the electrical safety device when the car leaves unlocked doors. So UCMP prevents fall hazard and stabilize even when the car or the drive system fails. So this must be independently monitored and functional. The next comes to the electromechanical brake. So as per the norms and standard, so it is important to have an independent electromechanical control for the machine. We need at least two electromechanical devices to play the brake on the machine, and along with its feedback, that is important. So having the brake is not only the need, we should also monitor each brake separately to ensure that electromechanical brake, two independent electromechanical devices according to whether or not integral part with those which cause the interruption of current feeding to the lifting machine. It can be part of the output conductor or it can be a separate conductor, but ensure these arms are operated separately with the feedback. And furthermore, the brake system overview, the brakes shall be capable of stopping the lift machine under the most enormous condition, which is car traveling down with a rated load down at a rated speed and with the rated load plus 25 percentage. Overall 125 percentage, the car traveling down, the brake should able to capable of stopping the elevator if needed during the safety action or safety brake, safety circuit brake. So redundant mechanical design, which means we need a two set of brake for for meeting this requirement. So with the independent control as well as the feedback mechanism. So this ensure the key feature as listed here, brake alone can stop the machine with rated load plus 25 percentage when the car is traveling down at rated speed. Mechanical components involved in braking action are installed in at least two independent sets. Two independent electromechanical devices actuate the brake, and independent ensure single fault tolerance. Each brake can be tested independently from the outside wall. This is to ensure the proper function of the brake, ensure high level of safety and reliability. So the next one is the emergency operation. So this is a emergency operation requirement of 5.9.2.3. So power supply requirement. The power supply shall be able to move the car with any load to the adjacent landing within 1 hour after the breakdown. So this also important that car can be moved to adjacent landing within 1 hour after the breakdown. Even with the main power available or not available, we should have a standby power or with the main power. So we need to have 1 hour backup. If needed, we should able to move the car after the the breakdown. And the speed limit. And the speed limit during this operation should not go beyond 0 0.3 meter per second. And location of means to actuate emergency operation in the machine room, in the machine room cabinet, on the emergency or test panel, like when you are going for MRL. So the key point is like electric means independent from the normal supply and capable of moving the car with any load, and must reach an adjacent landing within 1 hour. Speed limit of maximum 0.3 meter per second. Actuation located at one of the three specific places. So the next one is 5.9.2.5, removing the power which causes a rotation of the motor. We can follow any one of the method. One of the method shall be remove the power which can causes of the motor, because as per the standard we can follow any one of the method. The first one is two independent contactors to control the motor, which are routed through the safety circuit to ensure the breakage of the uh, safety circuit causes the contactor to drop with the monitoring function if you are not using the safety circuit. And a system consisting of a conductor interrupting the current at all port, the coil of the conductor shall be released at least before each run in the direction. And a control device blocking the flow of energy in the static element, definitely the VFD based, and a monitoring device to verify the blocking of the flow of energy each time the lift is stationary. So this is the elevator logic with the VFD to ensure this single conductor with the VFD element to control this function. And the next one is electrical safety. Electrical safety satisfying 5.11.2.3. With that also we can, this means is recorded as a safety component and shall be verified according to the requirement of 5.6 of IS 17900 Part 2 with the certification. And adjustable speed drive with the STO function, where the drives comes with the STO function to monitor, and the STO function being controlled with the safety circuit to ensure the disconnection of the power to the motor upon whenever it is needed, or the safety function need to be activated. The next one is a motor runtime limiter, which is 5.9.2.7. The condition smaller of 45 seconds, or time for traveling the full travel in a normal operation plus 10 seconds, or with a minimum of 20 seconds if the full travel time is less than 10 seconds. So you can see the block diagram. So this is to explaining that the travel time measurement. Like if your travel time by default, you can the highest value must be 45 seconds, not more than that. But if your travel time is lesser, so we can consider like travel time plus 10 seconds. Total full shaft travel time, bottommost floor to the topmost floor. Total travel time plus 10 seconds. Or else we can consider if the travel time of the bottommost for the top floor is less than 10 seconds, we can consider 20 seconds as a runtime limiter. So when the system reaches this timing, the system should automatically stop the elevator if it is not stopping within the defined motor runtime limiter. This is the requirement for this one. And next one, this part is quite big, but briefly I have taken the points to discuss here. So this is about 5.10 electrical installation and appliance. The scope and application. So main power circuit, dependent circuit, car light circuit, dependent and well light circuit and dependent. So these points is focusing on the scope and the applications, focusing on this point. And electrical equipment requirement. So the suitability we have to check for the application and standard IS, IEC and follow the instruction. And EMC requirement. So as per it should meet the IS 17805 part 1 part 2 for the inductive and the conductive. And mounting and accessibility. So the mounting and accessibility. Control panel placement is important with the front access and 0.4 meter to 2 meter for the device access. If these devices are need to be maintained or to be used for carrying out the any activities like breakdown attending or maintenance. Protection against electrical shock for a direct contact and 30 milliampere RCT for the voltage higher than 50 VAC for landing and car circuit. So this is to ensure that because the human is so sensitive body, if the 30 milliamp, more than 30 milliampere can even kill a man. So to protect the people who are working inside the control of the using the elevator, so it is recommended to use. It is not recommended; it's mandatory to use 30 milliampere RCT, which can sense the residual current along with the short circuit and low voltage current. So this device 30 milliampere is applicable when the voltage more than 50 volt going to the car top. It can be a car lighting, a shaft lighting, or door motor power supply or safety circuit. So we must use the 30 milliampere RCD to protect against the electrical shock. And insulation resistance, as per the requirement, the earth to live conductor wiring, so should have a sufficient insulation, which is 1 mega ohm, depending upon the voltage range, and the testing measure has to be used to measure that. And next one is the incoming power supply and main switch control. This has to be ensured that inside the panel we have to carry out any activities while we are switching off inside the panel or in the machine room. We have to ensure that we should able to disconnect all the power supply except the power supply for the socket lighting, machine room lighting, car lighting, and shaft lighting, which needs a separate the control switch to switch off. But we have to consider while we are switching off the control power supply, we have to the circuit should ensure along with the UPS power supply. While we are disconnecting the power supply, we should also disconnect the ARD power supply to avoid the unwanted movement of the elevator while we are trying to do the activities after switching off the main power to the controller. And protective earthing as per the IS 732 and the electrical identification. This is more important. All the common as per the voltage range has to be identified clearly, including the required identification of the every components and the voltage range, and the caution notice has to be placed for the all the components, including the machine room and the panel. So the 5.11, this is about the protection against the electrical fault, failure analysis, and electrical safety devices. So this 5.11 is a elongated subject. So concentrate on the key point, the general 5.11.1.1. If any single part cannot be excluded, it shall not on its own be the causes of the dangerous malfunction of the lift. For safety circuit, we have to refer the 5.11.2.3. So lift considered as a whole built-in electrical equipment. It complies with IS 1650 part 1 and IS 17805 part 1 and 2, that AMC. And the electrical actuator as per the IS 16503 and part 2. the earth fault response. So earth fault in safety break or down the wall circuit, or immediate stop the machine or prevent the restart after the first normal stop if the first stop alone is not dangerous. Return to service only by manual resetting. So this is a basic need for the earth fault response. And electrical safety devices. So during the operation of any electrical safety devices, the lift movement shall be prevented or stopped immediately. So we can see all the electrical circuits are looked in series to control the operation of the machine, and any breakage will lead to the elevator stopping immediately. No parallel connection with safety devices except perimeter, and no external signal may alter the output, and record delay circuit shall not delay stopping. Internal power supply shall not cause false symbol. And the safety circuit for terminus rules. The first fault, we can see here the chart. The fault, first fault and second fault. If the first fault combined with the second fault can lead to a dangerous situation, stop at least at the next operating sequence where the fault element should be participated. Further operation impossible with the fault resist. And the next one, two fault plus third fault. If two faults which by themselves are not dangerous can lead to a dangerous situation with the third fault, stop at least at the next operating sequence where one fault element should be participate. And more than three fault, if combined of more than three fault designed with a multiple channel monitoring circuit checking equal status, if different status detected, stop. For two channel monitoring circuit checked prior to restart. And the power restoration. After power restoration, stopping reimposed at next sequence in case of A and B and C. Need to keep left stop during power off. And redundancy circuit. In redundancy type circuit, limit common cause failure through design measures. So here comes the 5.12, the control, final limits and priorities. So control lift operation, the control of normal operation through buttons, touch, card, etc. In enclosed box, no live parts accessible. So that is important for the control of normal operation. And yellow color only for alarm installed device for the emergency, and control clearly identified by function IS 41905. And the visible notice or signal, person in the car shall know at which landing the lift has stopped. Stopping accuracy plus or minus 10 mm with a VFD based elevator. And if leveling accuracy exceed plus or minus 20 mm during loading and unloading, it shall be corrected to plus minus 10 mm where ECMB is taking place. Here the important part, because we are going to run the elevator keeping the door open by doing bypassing the safety circuit. So stopping accuracy play a key role where when our loading unloading causes a level accuracy issue. So like a rope due to the rope elongation. Load control prevent normal starting, including releveling if overload in the car. And overload detected at least when the rated load is exceeded by 10% with a minimum of 68 kg in the ratio per person. In case of overload, audible and visible signal in the car, automatic door fully open position during the overload, and manually operated door remain unlocked, and preliminary operation nullified. Next is the inspection operation. So inspection operation station location can be on car roof, pit, maintenance platform. The next one is this. So consist of inspection operation switch with the bistable function, up and down direction push button, run push button, stopping device, the stop switch, door control switch option. Key functional conditions: neutralize normal control, disable emergency electrical operation, disable leveling and releveling, prevent automatic door movement. Speed must be limited equal to or less than 0.63 meter per second. Speed limit 0.3 when clearance is 2 meter from the roof or pit. When we can consider like reaching the elevator to the terminal slowdown in the upper bottom. Limit of travel not overrun, dependent on safety devices for multiple stations simultaneous operation required. So emergency, apart from that inspection operation, even for the inspection operation, it is mandated to follow the coloring, the button for up must be white, and run button must be in blue, and down must be in black, and even the arrow color also has to be followed for the inspection station placed in car top pit or maintenance platform. The next one is the emergency alarm intercom system and automatic rescue device. So here the focus is emergency alarm bell on emergency supply. Must be powered with emergency power supply. Audible outside lift well, especially at destination floor. Operable from car roof, pit. Considering like if people car inside car is for the passenger, car roof and pit is for the maintenance people if they got stuck on the car roof or pit, so they should also able to communicate with outside people by pressing the alarm button. Intercom or similar device on the emergency supply for the communication between inside car, outside place of emergency operation, require if travel more than 15 meters or direct acoustic communication not possible. The case is the intercom and communication is mandatory. So the next one is the automatic rescue device, which is the functional principal function. So normal operation, main power available, main and power fail detector. So safety circuit checked, and if yes, ARD activated, links to the nearest possible landing, door open, exit the passenger. If the safety circuit is not closed properly, ARD should not operate. So key point highlighted here is ARD ensures safety rescue to the nearest landing during power failure. Operates on battery power with adequate capacity for at least 3 rescue. Audio visual alert and emergency light ensure passenger awareness. Stop accuracy with plus or minus 40 mm accuracy. Works under phase failure, phase reversal, and only when safety circuits are healthy. But phase reversal, if the circuit has been, like for the motor is being used with a VFD, phase reversal will not make any impact. No need to consider the ARD operation. Priority and time delay ensure safe boarding and movement. Clear sign guides the passenger to collective control. So these are the key points. Comes under the IS 17900 Part 1, focused on the control part as well as the electrical part. So now we will move to the Part 2, which is the design rule calculation and examination. So this is part 2, published in 2023 along with part 1. I left for the transport of person, goods, design rule calculation, examination, and test of lift components. So I have considered the key item which is related to the control circuit and the control panel circuit. So here 5.6, the type examination of the safety circuit containing the electronic component and or programmable electrical system, the PESLA. Safety device input like door, lock, safety gear limit switches, buffer, etc. So these are the input safety circuit, giving the input condition, and electronic safety control and PESLA logical processing. And diagnose the fault monitoring, self-test, crash monitoring, and the fault detection error log. So safety output can be through STO, brake control, contactor control, along with alarm and indication, and lift stop in a safe condition. So brief is like verify the safety circuit. Vessel perform the required safety function correctly under all conditions. Confirm fault detection, diagnose, and tolerance against a single fault. Ensure loss of any power supply, internal fault, or detected error result in a safe state. That's stop. Assess software integrity, parameter protection, and resistant to environmental influences when the electronics is being programmed for the safety circuit. So that is important. Validate documentation reference and behavioral proving test. So this is for the personal condition test examination. And type test for the ACOP, ascending car overpeak production means. So ascending car overpeak production start with the speed sensing of the controller via car absolute position of the counter or encode based. So signal condition based, whether the lift is reaching rated speed or beyond that. Overspeed evaluation compared with the ACO limit. And decision making, if the speed is more than defined, then chip output independent safe circuit, which can break the circuit. And immediately the brake, if we are using the brake as a ACOP function, apply the brake through the safety circuit or the controller. Safety gear actuation, if the ACOP is to, via the governor safety gear, because the safety gear can act on car or counterweight via the governor function and controls safe stop. So the brief is ensure continuous monitoring of the car speed in up direction, confirm overspeed detection at or below the declared limit. Verify is independent of actuation of brake and safety gear. Check stopping performance within the perimeter distance and validates reset condition and prevention of automatic restart. So this for the ACOP function type examination. So the remaining two key points is 5.8 type examination of unintended car movement protection means. As we discussed before on the ACOP, if the brake is being used for the stopping element, so it can meet both 5.8 as well as the 5.7 with the functional logic. So for the ECMB, the system detect the door zone position monitoring, including door lock, car position level detection. If the system detect unintended car movement, yes, activate the UCMB function via brake or safety gear or by mean which is stopping the movement of the car or machine shield. Stop the car within allowed distance, fault indication and manual reset is required. So otherwise, the normal condition can proceed on. So brief is ensure detection of unintended car movement of the car away from the landing with the door unlocked. Verify immediate activation of the stop device because it should stop within 1.2 meter, not more than from the floor level with sufficient door guard. That means the opening gap should not be more than 200 mm. Confirm car stop within the specified perimeter distance. That is important. Ensure indication of event and manual inspection reset before return to the service. 5.15, which is electronic component failure exclusion. So the component selection design review is important and reliability assessment and environment stress testing and failure exclusion decision, failure rate, and common qualify for the safety application. So demonstrate that the certain electronic common failure are extremely unlikely to occur based on design and quality control reliability data, test result, and operation condition. Such a failure may be excluded from the further consideration if safety analysis and reducing unnecessary redundancy. Documentation of criteria, data, and justification is mandatory. So these are the two part which is IS 17900 part 1 and part 2, focusing on the controlling element as well as the electrical part. So I have highlighted the key point and I'll just go through our product which is meeting this standard. So you can see here we have got a complete solution which is meeting the IS 17900 part 1 and part 2 with a complete E package or with the control element with the VFDs 1000 plus 3000 plus and streamline control along with the complete E package meeting our IS 17900 part 1 part. These are some of the product certification, which is EN 8120 and 50, which meeting the IS 17900 with additional local requirement. Yes, thank you everyone. Hereby, I'm finishing my slide. Now the time for the question and answer. So I think Neelam, we can
Yes.
start this session.
Thank you,
So
Subra sir, for the informative session.
yes,
Uh, Attendees, now you can put down your questions in the Q&A box.
or any live question also can be answered.
So there is one question, anonymous question. Is LOTO requirement as per IS standard?
Yes, actually, LOTO is required to ensure the person who is switching off the power supply must do this lockout tagout to ensure someone else will not operate the power supply. So LOTO is required.
Is there any other question? Yes. There's one more question. One second. So how was EMC compliance was checked and verified?
So the standard, it is clearly defined in our IS standard. So the conductive and inductive for the complete control panel and the necessary component, including door drive and the key component which is generating the high noise. So it has to meet this the MC conductive and inductive. Uh, I think I'll take to the page. So it is clearly defined well uh, in the standard, which is IS 17805, part 1 and part 2. Part 1 is for the conductive, part 2 for the emission. Because none of the, many of the drive available in the market will not directly meet the CMC requirement, where we need to add the filter. Not only for the drive, we have to consider the entire panel to meet this EMC requirement. Yes.
Shall we move on to next question?
Yes, yes, yes.
Next question is from Mr. Kumar. Any certified lab available in India for IS 17900 to testing components?
Right now, actually, there's no authorized certifying body. So only inspection body is available, but no authorized certifying body approved by BAS. I hope the government is working on it, but right now the certification is self-certification. So as per the standard, we have to do a testing and ensure that our component meeting the requirement. So tests, examination is need to be conducted by our with our own test lab. Yes.
We will move on to next question.
Yes.
Next question is from Mr. Mithul. Which part should be included for fully compliance of IS 17900 in controller?
Uh, Actually, if we go in detail, like selection of component, the start with the EMC and RCD selection for the voltage more than that, and identifying all the components, and the selection of components should also meet the EMC requirement, and the same component should meet the our IS standard. Any component selection within the control cabinet. So all component we are selecting should meet the local code, which is IS code, applicable IS code for the including conductor, transformer, and the drive, as well as the the other important factor, including the EMC filter, if you are using to meet the EMC requirement. Yes, that's one.
Next question is from Mr. Shane Bagaraj. Any any certificate obtained from NABL accredited lab or
No,
accredited
actually,
lab?
yes, for aggregated lab, yes, for the Saturn, I know, like for NABL aggregated lab available for the EMC certification, where we can able to meet, and they're also doing some additional requirement as per the job site requirement or the customer requirement, but not for the IS 17900 part 1 part. There's no aggregated lab to give a certification for IS 17900 part 1 and part 2. Some classes which is already available in India, like EMC requirement, IP rating kind of a thing already, there are some labs available aggregated by the NABL who can able to give.
Okay.
Yeah,
We'll
next.
move on to next question.
Yes.
Anonymous question. Can you share the presentation for reference? We will upload this recording on YouTube, so you can refer to that.
Yes, yes.
We'll move on to next question. Next question is from Mr. Sevlaram. Door should remain open after ARD operation is over.
The purpose of keeping the door open, there's no specific, we can keep the door open for the purpose of not the people to get in there, because there won't be a sufficient lighting inside the car. It is recommended to keep it open. But we need a defined power supply, which is not possible because the rescue operation again, with the rescue operation will take place with the standby power supply. So holding the door with a mechanical means it's okay. Otherwise, it has to be closed with, I hope, with a defined timing. Let me check it out. There is a timeline. After that, it can close to ensure that there is nobody inside the car. But even if close, the door open button should work inside the car if the power remains there in the controller. Yeah. Next.
Next question is from Mr. Rajesh. Hydraulic buffer is required for 1 meter per second speed limit.
Uh, Actually, hydraulic buffer, unfortunately, so I need to check this because this is a mechanical. I'm sorry that I have not focused on this one.
Moving on to next question. Next question is from Mani Kandan. Is it mandated now or voluntarily for lift manufacturers for IS 17900 standard?
Actually, as per the government, it is mandatory to follow IS 17900.
Next anonymous question. What are available? RCD or RCBO rating in India market?
We can go with the combined function of current leakages or independent function like the MCBO function with the residual current device separately, or combined, because now there are some devices already available with the RCBO which can residual current circuit breaker with the function of detecting leakage current as well as the over current as well as the short circuit current, but it is not widely available. The cost of the device is quite expensive, but I hope soon the production will increase and the cost will come down. Now, yes, is the availability of this component is there, but a high cost.
We'll
Yeah,
move on to
next.
next question. Next question is from Mr. Rajesh. RCD required is type A or type B?
The selection of RCD, we have to consider because the application where we are using, because we have got a SI is the specialized RCD to control the pulse output, because when we are considering the output from the high noise voltage which is more than 50 volt, RCD should able to detect, but the applicable list can be met with the A also. The latest RCDs are quite better to work on the different kind of output power supplies.
We'll move on to next question.
Yes.
Next question is from Mr. Vishal. For UCMP, two independent brakes are compulsory. Can we use bi-directional overspeed governor to stop the lift in case of UCMP?
Uh, UCMB and ACOP, there are two different. Especially for the UCMB, there is a limitation to stop the lift within 1.2 meter due to the severity compared to the ACOP and UCMB. UCMB, the lift is running, keeping the door open condition. So we cannot rely on we can rely on our governor based on the continuous monitoring, the independent monitoring with a reaction time within 1.2. At the same time, this system should also activate the safety gear. When we are going for a governor based means, we have to consider the safety clutch. If you are going with the brake, then we need a separate monitoring to through the safety relays to activate the brake on time.
We shall move to next question.
Yeah, next.
How to test ACOP and UCMP at site.
UCOP and UCMP, we have from the controller supplier. They will provide the procedure to follow, like to activate the system to run. ACOP means nothing but it has to run more than the rated speed. And the controller supplier will give the special function to run the elevator more than the rated speed. And then if it is sensed with the governor based solution, it can able to act, and the ACP can be tested, and at the same time the system also will display when it reaches the higher speed specific for the ACOP. And UCMB, again the same thing, like there will be a special circuit to activate the UCMB function to ensure the elevator stop within the limited distance in the landing. Next.
Next question is from Mr. Kostu. Is battery low signal required in ARD?
Yeah, it is recommended. The battery low signal is recommended with announcement inside the car when you are using the ARD.
Moving on to next question. Next question is from Mr. Raj. What about the fire evacuation phase 1 and phase 2 features? It is mandatory. Is it mandatory for this functions to comply with the IS 17900?
Yeah, actually, a fire phase definitely for every lift should have a phase one function, and phase two function when the travel height is 18 meters, so more than that, and there must be a one at least one elevator with the phase two function, which is a fireman operation. So as per the standard, it is mandatory every lift to meet the phase one function. Next.
Next question is it compulsory to BIS certification for IS 17900?
No, currently there is no certifying body for IS 17900, and there is no authorized body approved by the government or the BAS. Now it is self-certification where we should able to prove ourselves the product has been tested and meeting the standard if it is questioned by the authorities.
Next question is from Mr. Raj. Anything mentioned in IS 17900 about minimum size of a rope to be used for speed over speed governor?
Yeah, the limitation is there, is specified, yes.
Next question is from Mr. Kostub. Is low battery indication and announcement is mandatory display and audio?
Actually, the reason for display and the audio for the, the easy access by the user, because everyone should able to understand what the ARD or low battery indication, or usually both, like an indicator with audible is recommended. Next.
Next question is from Mr. Anand. As per safety standard, what is the timeline to complete the ARD operation?
Like they have not defined the particular timing, but the basic requirement they have given is like per charge. Without the next charge, the system able to continue the three consecutive rescue operation to the nearest landing. So that is important with a single charge by the ERD.
Next question is from Mr. Vishal. UCMP brake will only be operated during UCMP, conditional only. Separate controller to detect UCMP is required.
Can you just repeat the question again, please?
UCMP brake will only be operated during UCMP condition only. Is there separate controller to detect UCMP is required?
Actually, if the system is having the built-in redundancy, there's no need of a separate system. Considering like the brake and the control system with the built-in redundancy, we can use the same system for doing the activating the UCMP function.
Next
Next.
question is from Mr. Rajesh. The ARD announcement is after ARD start or when the power fails.
It is mandated to indicate the passenger during the power failure, but when it take place immediately, we cannot announce because there won't be any power. The moment the power comes to the system should start announcing the ARD because the ARD system will take over immediately after a power failure within 10 seconds. So there's no problem with that. Next.
Next question is from Mr. Shane Bagaraj. RCD with 30 MA setting will strip nuisance due to VFD drives. How is this issue taken care?
Actually, this 30 milliampere RCD is not for the VFD. This for the other power supply, which is more than 50 volt, going to the car top, car light, shaft light, and safety circuit kind of thing. So this 30 milliampere will not get affected because we are not going to use it for the VFD. Next.
Next question is from Mr. Vishal. In UCMP, if we use independent brakes and due to rope slippage, UCMP is detected, how the brake can stop the lift?
Actually, losing traction is has been not considering this UCMB fact because UCMB is not considered for the losing the traction. The rope losing the traction is not being considered for this case.
Shall
Next.
we move to next?
Yeah.
Next question is from Mr. Rajesh. Is BIS certification required for V3F drives as per IS 17900?
Can you just repeat again, please?
Is BIS certification required for V3F drives as per IS 17900?
Currently, actually, there's no separate certification for the VFDs as of now. We actually earlier the government planned to introduce in general category, but now that is on a hold. Hopefully, it will come back soon. Next.
Next question is from Mr. Kumar. How to stop how to stop car moving due to overloaded or another reason even motor is not in working and ropes are sliding in the groove.
Actually, this is a mechanical factor. Hopefully, it should not happen because the traction, the rope losing the traction with the sheave is a big element. I think that particular moment has not been clearly described in this IS. But normally, for losing traction and moving the car down, the only option is our governor, safety governor. This is already available to stop the elevator with the safety gear.
Next
Yeah, next.
next question is from Mr. Kostu. How mechanical safety will work when uninterrupted car movement, as UCMP will give only output for mechanical safety?
Yeah, one more time, please.
How mechanical safety will work when uninterrupted
Mhm.
car movement, as UCMP will give only output for mechanical safety?
Actually, there is a clear-cut definition. Even if any product being used for any one of the factors being used for ECMP function, whether it be brake or even a safety gear, so the performance must be taken care that the retardation, which means the retardation timing should be within the limit so that the car can be stopped within 1.2 meter. So certification, like if you are going for the safety gear based solution with the governor, or if you are going with the brake based solution, we understand the reaction time for the mechanical will be slower than the electrical devices. But the consideration is so important that we have to consider the maximum distance. The system should be able to stop the elevator within the distance of 1.2 meter. If it is not able to stop the elevator within this distance, so the device is not qualified. Let it be the governor and safety gear based UCMB certified product or the brake UCMB certified product. It will not get eligible. Yes. Next one.
Next question is from Mr. Raj. For elevators already installed and in operation, is compliance with IS 17900 mandatory through retrofit, or will the standard apply only to the new installations and major modifications?
Actually, for the modernization, the government has released the new code for the mod job. I think so. When it becomes the mandatory, I hope everybody will start to, because we have got a standard which is IS 17900 Part 10. This for the replacement of existing passenger and goods lift. So we have a standard published in 2025. We have to follow that. New elevator, we can follow the part one and part two, whereas here for the existing elevator, we need to follow part 10.
Next question is from Mr. Kostub. Is five-way intercom is mandatory in IS 7900 compliance?
Actually, it's a Cartesian based when the travel distance actually is more than 15 meter. Then we have to provide the intercom, because the communication between the machine room person and the car stack people may not able to communicate well inside the shop. So it is the standard specifying that if we are not able, even direct acoustic communication is not possible, then you should have intercom to communicate with the people inside the car and outside, or the emergency operation is placed. This is mainly to used to for rescuing the people during the rescue operation. Next.
Next question is, if brake fails in case of UCMP, how lift will stop? Is any separate device is required?
Actually, the main reason brake failure, because this is the main reason. The recommendation from the standard is we should have a two independent brake unit to ensure that the even one fail, the next operation will be suspended, and the system, if the single another brake, it should be able to stop the elevator. So that is a two independent control to control the machine shield. So it is not a single brake. The operation also independent and feedback also independent. Next.
Next question is from Mr. Sunil. Is that all IS Indian standard norms are implemented in Monarch products with ARD battery low indication, scroll in display?
Yes, actually, this has been implemented in the Monarch controller, the platform NICE 1000, 3000 plus and 1000 plus.
Next question is from Mr. Rajesh. Is emergency window was compulsory in headroom area for MRL jobs?
The standard requirement is the visibility of the car movement is important. So this comes under the maintenance purpose. Hopefully, by referring to the suitable code can help to give the clarity on that. Ultimately, the movement of the car is important when we are doing any emergency operation to rescue the people. Then it is important. If it is not possible, then we should have the the emergency panel where we can able to see the movement of the car, direction, speed, and all. The maintenance purpose, yes, definitely the accessibility to the mission can be recommended to have. Next.
I think so. That's all with the questions, sir.
Okay, okay.
That was a good interactive session, sir. Thank you so much for sharing your technical knowledge and the informative session on IS 7900 on electrical equipments. Actually, we truly appreciate, and on behalf of IC and Innovance, we thank you for sharing your expertise with the industry today.
Yeah, thank you, Neelam, and thank you everyone for your patience. Almost more than 1 hour. Thank you, everyone. Thank you so much.
Yes, and thank you all our audience who have joined us today. I hope this session was very thoughtful for you. And as a reminder, our session happens every Tuesday. Our next session will be on 28th July. Thank you once again, all. Let's stay connected. See you. Have a good evening. Thank you so much.